So in this video, we're going to talk about another essential simple machine, this time pulleys. And pulleys are, again, another type of simple machine that consists of a freely rotating wheel, so this can spin as it pleases, with a rope or chain wound around it. And pulleys are used to raise or lower objects with the load attached to one end and effort applied at the other. And there are three main types of pulleys that exist, and they each have different functionalities or properties and applications. So the first and simplest type of pulley is called a fixed pulley. And in a fixed pulley, as the name suggests, the wheel is fixed in place, which we can see in our diagram here, and the pulley only changes the direction of effort. It doesn't reduce the effort. So, for example, in our illustration here, this load is lifted by applying effort downwards. So without a pulley, you would have to apply effort upwards in order to lift the load. But a fixed pulley redirects that effort to align with the gravitational force. So this makes it easier, but this is not to be confused with reducing the effort. So in a fixed pulley, the effort and the load move the same distance. And a common example of a fixed pulley in everyday life is a flagpole, where a fixed pulley is used to raise the flag on a flagpole by pulling down. So the next type of pulley, the second main type, is called a movable pulley. And again, as the name suggests, in a movable pulley, the wheel moves with the load, and the effort and the movement of the load are in the same direction. So again, referring to our illustration here, rather than being fixed in place, actually the pulley will move with the load. So as the load moves up, as the load is lifted, the pulley will come with it. So in this case, they do reduce the effort, but increase the distance over which effort is applied. And this is what affords pulleys with mechanical advantage. So you're essentially increasing the total length that needs to be pulled, so the effort distance is greater, but this reduces the effort, so it makes it easier. And one common example is a construction crane. This is how cranes operate. They used movable pulleys, and often complex systems of pulleys, to raise a heavy load by increasing the distance and making it easier to lift that load. And lastly, we have a system of multiple pulleys. And in these systems, we can combine both fixed and movable pulleys to essentially get the best of both worlds. They will change the direction of effort to align with the gravitational force, and they will also reduce effort. So, for example, in our simple system, this is just a simple of two pulleys here. We have one fixed pulley and one movable pulley. Well, we see that the fixed pulley serves to redirect effort downwards, and we see that the movable pulley will help reduce effort. So again, systems of multiple pulleys combine the benefits of both fixed and movable pulleys. And one common example in everyday life of pulley systems is an elevator. It uses both types of pulleys to make it as efficient as possible, reducing the effort to raise and lower people within a building. So let's take a look at a few different configurations and consider the mechanical advantage in a bit more detail. Well, for pulleys, the mechanical advantage is simply the ratio of the load divided by the effort. So if we want to lift a load with a fixed weight, we can't do much to change the load, but we can reduce the effort. So the greater the effort reduction, the greater the mechanical advantage. Now, for a pulley system, to determine the mechanical advantage, you need only to count the number of ropes that are used to support the movable pulley. So therefore, the more ropes, the greater the mechanical advantage. So for example, in the left part of the illustration, we see a pulley system. We have one movable pulley and one fixed pulley. So only the movable pulley will help to reduce effort. So let's count the number of ropes that are used to support that movable pulley. Well, we have 1, 2. So because we have 2 ropes, therefore, we're reducing the effort in half. And again, the fixed pulley doesn't serve to reduce the effort, but only to change the direction of effort. Now, on the right-hand side of the illustration, we have only that fixed pulley. So again, there's no reduction of effort. It makes it easier insofar as pulling down and aligning with the gravitational force is easier, but this is not equal or equivalent to a reduction in effort. So let's take a look at another, slightly more complicated example. In this case, both sections of the illustration are pulley systems. So let's try to determine the mechanical advantage of each system. Well, again, we can count the number of ropes that are used to support the movable pulleys. So on the left, we have 1, 2, 3. So we're reducing the effort to a third of the original value. In the right-hand system, we have 1, 2, 3, 4. So instead of reducing it to a third, this system will reduce the effort to a quarter. So that means the right-hand system has a greater reduction in effort. Again, the more ropes, the greater the reduction in effort, and therefore the greater the mechanical advantage. Let's summarize the important information we've learned about pulleys. There are 3 main types of pulleys, and pulleys are a simple machine that are used to lift heavy loads. The first type of pulley is called a fixed pulley. And in a fixed pulley, the wheel is fixed in place and the pulley only changes the direction of effort. It does not reduce the effort. And then we have the second type, a movable pulley. And in a movable pulley, the wheel moves with the load and the effort and movement of the load are in the same direction. So you increase the total distance and you thereby reduce the effort. Then we have a combination of the two. So we have a system of multiple pulleys. So this combines the best of both worlds of both fixed and movable pulleys. So this will change the direction as well as reduce the effort. So again, here we have a little bit of a summary of this. We have fixed pulleys, change direction. We have movable pulleys, reduce effort. And then pulley systems do both. They change direction and reduce the effort. And if you want to determine the mechanical advantage of a pulley system, you need only to count the number of rope sections that support the movable pulleys.